Okay, so chapter 7 is all about something called stoichiometry. So, stoichiometry has to do with ratios and quantities in chemical reactions. So, we're going to do some calculations in chemical reactions and determine how much of something we can make if we're starting out with a certain amount of different reactants. So, let's just start at the beginning, make sure everybody is on the same page. So a chemical reaction has a few different pieces. It has reactants on the left-hand side, and it produces products on the right-hand side. Most of the time, chemical reactions have coefficients. Coefficients are the molar amounts of the quantities, the reactants and products in that equation. So let me just use an example. So let's say here is a chemical equation. Okay, so Sr is the element strontium, and then O is oxygen. So if I asked you to write a sentence about this chemical equation, what you would say is 2 moles of strontium reacts with oxygen to produce 2 moles of strontium oxide. So it's going to be really important that you can read a word problem, a sentence, and write a chemical equation. So 2 moles of strontium, that's what this big 2 here in the front is called. So coefficients tell the molar amount of a species. And we use the word species in chemistry to just mean a reactant or product. It's either a compound or an element or a molecule. So 2 moles of strontium is this big 2 here. Reacts means it's a reactant. 2 moles of strontium reacts with oxygen. Remember, oxygen, this is one of our diatomic molecules. So when you read the word oxygen, you know that O2 goes here. So keywords, 2 moles tells me I have 2, a coefficient of 2 in front of strontium, reacts with oxygen. That means all of this is reactants. So all of this is reactants. And then it says to produce, that means now these are our products, 2 moles of strontium oxide. So that means this over here on the left, these are my reactants. This over here on the right are my products. It doesn't have to be written this way. It could have been switched. It could have said strontium oxide is produced by the reaction of 2 moles of strontium with oxygen. So they do not have to be worded this way. You just need to be able to interpret the sentence to determine what are the reactants and what are the products. So look for keywords like produce or reacts. Make sure you're paying attention to molar amounts in the reaction. So what the stoichiometry is it's the mole to mole ratio in this equation. Stoichiometry is the mole to mole ratio in a chemical equation. So what the mole to mole ratio means is I'm going to say 2 moles of strontium, 1 mole of oxygen will produce 2 moles of strontium oxide. So the mole to mole ratio in this equation would be 2 to 1 to 2. It takes 2 moles of strontium and 1 mole of oxygen to produce 2 moles of strontium oxide. So this stoichiometry is going to be really important when we start doing calculations because we'll need to use this mole to mole ratio. You'll either hear me call it stoichiometry or mole to mole ratio. It means the same thing. But remember, the big numbers in the front are the coefficients, and they tell us the number of moles of what we have in that chemical equation. Another thing that is really important is that chemical equations are balanced. So if we go back to talking about matter and the laws of thermodynamics, one of the laws of thermodynamics is that matter can't be created or destroyed, meaning whatever we have on the left-hand side, we also have to have somewhere on the right-hand side. So on this left-hand side, if I have 2SR plus O2 gives me 2SRO. So on the reactant side, I have 2 moles of strontium. I have 2 oxygens because it's O2. On the product side, this coefficient at the beginning means it applies to everything afterwards. So this compound, strontium oxide, means I have 2 strontiums and 2 oxygens. So this is balanced because I have the same number of atoms of all of the elements on both sides of the arrow. So this is important. You cannot proceed with a calculation about a chemical equation if the equation is unbalanced. So before we get too far, let's practice balancing chemical equations. So I'm going to write an unbalanced chemical equation and we're going to balance it. So these are unbalanced. The first thing that you'll want to do before you ever do any math with a chemical equation is make sure that it is balanced. So here I'm going to say potassium plus bromine produces potassium bromide. When I said bromine, I should have put KBr. Okay, I'm going to write a few and then we'll work through it. So let's say carbon disulfide plus oxygen produces carbon dioxide plus sulfur dioxide. And one more, let's look at magnesium plus hydrogen chloride produces magnesium chloride plus hydrogen. Okay, so these are unbalanced. So I'm going to balance them. So the way that we balance chemical equations, we need to make sure there's the same number of everything on both sides. There are many, many different ways to approach this. You do not have to balance the equation the same way that I balance the equation. What I do is I pick the molecular compound that looks like it's the most complicated, and maybe there's not a clear winner every time. And then I try to balance that one first and then balance everything else second. So it doesn't really work here because potassium bromide, I just have one of each of these. So if I look, potassium, I have one on this side, I have one on this side. The potassiums are balanced. But I have 2 bromine. So the only way that I can give 2 bromine to this side, I can't put a subscript here because we don't balance equations with subscripts. So you balance equations with coefficients. So I'm going to say I need a 2 here. So now that solves my bromine problem. I have 2 bromine, but now I also have 2 potassium. So can I balance the other side? Yeah, I can put a 2 here. So the mole to mole ratio is 2 moles of potassium to 1 mole of bromine to 2 moles of potassium bromide. You don't ever need to put the 1 here. 1 is implied. So if there's nothing there, that means you have one of them. So let's look down here. So here is carbon and sulfur, 2 sulfurs, 2 oxygens, 1 carbon, 2 oxygens, 1 sulfur, 2 oxygens. So this is a little bit tricky because oxygen shows up in 2 places on this side and only 1 place on this side. So this is going to be a little tricky. So I'm just going to choose to balance. I'm just going to pick this one arbitrarily. We'll just see what happens. So on this side, I have 2 sulfurs. On this side, I just have 1 sulfur. Remember, SO2 means there's 1 sulfur and 2 oxygens. So I need a 2 here. So now I've balanced the sulfurs. 2 sulfurs, 2 sulfurs. So now let's see what else. Now I've made myself 4 oxygens, but then there's 2 more. So now the total on the product side is 6. 2 plus 4 is 6. So that means I need a 3 here. So now I have 6 oxygens on this side, 6 oxygens on this side, 1 carbon, 1 carbon. So now it's balanced. So the mole to mole ratio here would be 1 carbon disulfide, 3 oxygens, 1 carbon dioxide, 2 sulfur dioxide. Let's look down here. Magnesium plus HCl gives me magnesium chloride plus hydrogen. Remember, hydrogen, another diatomic molecule. It's H2, not just H. Okay, so this looks like my most complicated molecule. I'm going to try to balance this first. See if I can balance this with it having a 1. So if this is 1 magnesium, 1 magnesium. 2 chlorine, I'm going to need a 2 here. 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen. It's balanced. These just take a lot of guess and check. There's no guaranteed way to balance it the first time every time. It just takes some practice. And you might arrive at the same balanced equation as I do in a different way, and that is totally fine. There are more examples of how to balance chemical equations posted on our page, and I will, as we go through each of these examples that we're going to do in this chapter, I will talk out how I balanced them. But this is something that some people, it's kind of like a puzzle that some people can see right away. And for other people, it takes a little bit of work. So practice balancing equations because this is the first step to doing stoichiometry and all of the calculations that we're going to be doing in Chapter 7.